You're very lucky if you like the way I'm doing it here, because you're maybe the 10th round of students that I had with Webassign. So initially I assigned Webassign for grade. Then eventually I assigned Webassign, and if you want to instead write out your answers and give it to me. And then I came to the point that I can't take that volume of students prefer to write it out and give it to me. So right now this is the way I'm doing it. I'm having Webassign not for grade as a tool. And the reason I have it like that is because Webassign is a computer, and the computer has some glitches with it. And one of the glitches that we saw this week, and thank you for telling me about this problem appointment with the so here's a perfect example of what can be very frustrating to students. So there was a problem on Webassign like this. Sure. Any human can see that. Maybe we can even teach a chimp that the answer is 6, right? But Webassign, it has an algorithm inside it, the way it finds the answer. It's a set algorithm because it's a computer. So it just starts turning the crank and running that algorithm. So for a while, when I was looking at that, I was thinking, well, where did they get this point? They got 0.28. Yeah. Like, where did they get 0.28 from? So I told her to try adding 2 pi to it. No, it didn't come out. Subtract 2, none of it worked. So I went on Maple and I did some calculations, and I did some back calculations, and I figured out why. Maple, by the way, is a piece of software that does algebra for you. And that's what Webassign uses as its way to calculate things. So if you put in an answer that's equivalent to the answer that's on Webassign, it will still accept it because Maple checks that it's the same. Well, Maple, what it was doing for some odd reason, is it was giving the answer -6 plus 2 pi. Now let's think about this. It's correct because cosine at 6 and cosine at -6 are what? They're exactly the same, right? But they took that -6 and added 2 pi to it. So let's think about why that is correct. Where's 6 on this is 2 pi over 2. This is pi, which is 3. This is 3 pi over 2. 6 is right. No, not pi over 6. 6, right? 6, the number 6. So this is about 3. Huh? Right around here, right?
Right there.
Right here, right? Yeah. So what it's saying is here, the cosine is the x value here, right? So for some reason, it was taking this value right here as its reference. And then it added 2 pi. Remember I joked with you, say stop saying, he did a complete 360. He did a complete 2 pi. So they just took that number and then rotated around it. It's right back to the same number. So this answer here is right over here. It's correct. It's very, very bizarre, but it's nothing wrong with it. And you are not wrong if you answer 6. In fact, you're human if you answer 6. If you somehow yanked this answer out of your butt, I have the utmost respect for you because I couldn't come up with something like that on my best day. That's a very weird way to answer that question. It's an algorithm. It's just got some kind of formula inside there, turning the crank. So if you come up with an answer where you believe you're right and you're following my instructions on Webassign and you get something different, do exactly what she did. She texted me. I was out someplace. I think I was in a store. I looked at it and went, 0.28, try adding this. I was giving her directions on back, and she's like, no, it's still not right. So then I went home and I did some calculations to try to figure out where in the world they came up with their answer from. And then I figured it out, sent her a text back and said, this is what they're doing. I have no idea why it's set up that way, but it's set up that way. So there's nothing wrong. And that's exactly the reason why I don't have Webassign for grade. These little problems, it's just one problem, but it can be so frustrating. And if it's for grade and you're being judged, it's stressful. And I don't think it contributes to learning, which is, I think, why we're here.
I wish Webassign showed you what you did wrong, or showed you the way to do it.
It's whatever algorithm it's in there. It's not the computer. When they show you what you do, or whenever they show you to practice it or whatever, they don't know about this Maple algorithm. They're separate things. So Maple is a expensive package that's as a piece of software, and it's using it. So they have an agreement with Maple to do this. So you would have to know all I can mention it to the people when they come here, but I don't think it's going to change anything. There's no other way to do it, right? You're having a computer try to simulate a human being, and sometimes the easiest answer is the correct answer. 6, that was the correct answer. The computer doesn't know how to do that because it's an algorithm. So that's one thing. The second thing I wanted to mention is, and I see it all the time because I teach all the time, but hopefully this is the first time you're taking me for pre-calculus. I have a friend who jokes around and says it's easier the second time around. But what I see every time. There's students who've been waiting for a professor like me to spell it out, explain what's going to be on the quiz, draw them step by step through the process, and they're taking advantage of it. I think we have like 10 hundreds on that last quiz that we had in here. People aced their way through the semester. And so if you are someone who is used to the normal way of math classes where you kind of sit back and kind of things are fuzzy and not clear and you ride the curve, it never works in my class because we get these bimodal graphs. People get hundreds or they get Fs. So if you're not on board, get on board fast. Get on board quickly because there's no reason for you not to get an A. Everything's spelled out. Everything's clear as a bell. And if you have any questions, I'm there. How many of you have been contacting me for extra help outside of class? Not too many. How quickly do I answer your emails or texts? Yeah, just like that. So that also is unusual. People are used to waiting for their emails to be answered to for days. None of that happens. I answer you quickly. I really mean it when I say students come first. So take advantage, and my goal is to get you to learn, to get you to really learn it right and learn it well so that I don't really care what you get in this class, I care what you get further down the line. I'm past all that point. I'm too old to worry about little things now. I'm worried about the big things. Okay, don't stop walking up towards the front of the class. Individual, if you have something, wait till the end of the class, right? Because it's me, I can't think straight. You can see that, like on the quiz that you just got, I need to be like organized, otherwise I can't think straight. I guess start making mistakes. That's another thing. If you come to me at the end of the class and I say, oh, sure, I'll do this and this and this for you. Dr. T, write it down. Because if I don't write it down or I don't put it in the phone, I'll never remember. Right? I might smile and promise you all kinds of things, but make sure I have it written down. Okay, we have an exam next Monday. Next Monday, we have an exam scheduled on the syllabus. So, you have similar problems to the quizzes. If you notice, I've been re-asking a lot of the same things again. So if that's another thing, if you're on board from the day one, you're sailing because the exams turn out to be pretty easy because you're just looking at the same thing again that you've already mastered. New stuff, there'll be some new stuff today. I'm going to spell it out again so that it's very clear. The other stuff is all old stuff, and I'm going to cover a little bit of that again in here. So Wednesday, I wanted to do a blood splatter experiment with you guys. Remember, we're going to have Jake from the Red Hawk Learning Center come here, and then we're going to do a blood splatter analysis. And I'd like to postpone that to the week after the day after the quiz, because I'd rather have an in-class assignment that was on the exam. So it kind of, you have a chance in here to resolve anything else that's left. Is that okay? It's a little bit more boring, but I thought, it's probably necessary. She's allergic to that idea. Are you allergic to exams?
Yeah.
So what do you guys think about that? Just switch the order so we do something more rote related to the exam on Wednesday, and then.
I don't know why I thought we did blood splatter analysis and it just went over my head. I'm like, did you do it?
No.
I don't know.
No, I didn't hit anybody on the head yet. Not yet. So new stuff is today. It's going to be circles and ellipses. However, it's not going to be completely boring because ellipses is one of these things that I had in classes, and I thought, even when I had to teach it, I was like, ellipses. And then lo and behold, the thing that you always think is, it comes back to haunt you. And I used it to look at the human body, the whole concept of the ellipses. And I know many of you said you're interested in going into a career in health. So I thought I'd show you this beautiful tool we built all from ellipses. It's It's really neat. So that's the last part of this lecture, which will be a little bit more interesting than the rope parts and should mitigate the fact that we're not doing blood splatter on Wednesday. Blood splatter is fun. So the in-class assignment, I kind of figured you'd want the in-class assignment to be like the exam, a little bit about the exam. It'll force me to get the exam ready tomorrow so that I'm all set and I know exactly what I'm going to ask you and I don't have a 4th page that has something from a previous quiz on it. And I'll have put in the rubrics in there too so that you can see where the breakdown is. No surprises. And that'll give you enough time to prepare properly. I kind of gave gloom and doom here in the beginning and told you that, oh, Pete, there's this crowd of people that go, oh, I was waiting for this all my life, 100. I can also tell you that everybody in my class, just rarely does it happen that they stay where they are. Most people start moving up. I have a lot of will, so I want you to move up. So if you don't have the will in you, I have enough for both of us. It's a little annoying. Okay, row problems here. This is more of the same, where you have triangles that you build with a reference angle. But in this particular problem, I actually like this problem because it asks you for all of the red list. See, it asks you for sine, cosine, and tangent, but then it asks you for the cosecant, secant, and cotangent. So let me review this step by step, like before. You've done this before, right? So you've seen it before. I just want to show you a couple more with these 3 on the bottom that you've never had with the cosecant and the, but they're pretty straightforward. Step 1, as usual, draw the triangle. By the way, your answers here should be not decimals. They should be the exact answers. Somebody has a Casio in here. Who had the Casio? Gives you the exact answers on. That's really nice. Okay, second step is to find the hypotenuse. You guys know this now who have already gotten hundreds on this stuff. You know the drill. The only problem that I saw, I think I still saw this, a couple people forgetting to put the negative number inside the parentheses. If you don't do that, what will happen? You get the negative here on the and it gives you the wrong answer for the hypotenuse. So I think that happened for a couple of you on the quiz. If it didn't, flag your quiz so you don't do it again. There's this weird thing about mistakes where people do the same thing again and again. Yeah.
And then a radiance, and I was putting it in something else.
Yeah, put it in radians. There was an experiment they ran with kids going into a physics class where they asked them questions about laws of motion, and they were wrong. Like they had it wrong in their heads. And the experimenter showed them they were wrong, and then they went through an entire physics course on laws of motion. And at the end of the semester, they took the same test they took at the beginning again. They reverted right back to their old mistakes. Yeah. And even if they had an A in the class. So, and I had done a little experiment with high school teachers. And we teach night classes with high school teachers in them. And they take a comprehensive exam. So I thought, well, I'll get them ready by giving them comprehensive exams in class. And the second test, what I noticed is people made the same mistakes that the same people made the same mistakes on the first test, even though I asked them to correct it. So they saw the answer, they gave me corrections. So the next time around, I asked them, tell me why you did it wrong. Write it out in words. I did this wrong because I thought this and blah, blah, blah. The third time they took it, they changed. They got it correct. So something had to intervene inside there to get them to understand. That's what I'm suggesting. If you got this wrong with the hypotenuse, flag it to yourself that you got it wrong so it won't happen again. It's the way, I think it's a human thing. Like we just think that way. We revert back to something that we did before. So step 2 is find the hypotenuse. Most of you are good with that. If you have a problem with that, just flag it to yourself and it won't happen again. So now I have the hypotenuse. And notice I asked you for the exact answer. So that's square root of 425. You see all these square root of 17s over there? So you have to break this 425 up. And that's not hard to do, unless you're in love. 425, remember this prime factorization tree that you can do it like that. You can just divide it out, do it on a piece of paper. But lo and behold, you see the 17 appear down there below. 5 times 5 times 17 is 425. Yeah, you will, because you know 5 divides 425, so you can just take 5 and divide 425, and whatever you get after the 5, see the 85? You'll know 5 divides that too. So when you divide by 85 by 5 again, you'll get the 17. Right? So it's not that bad. What the deal is that every 2 you have under that hat, you can take out 1. Right? So breaking up is not hard to do. You end up with 1 at the end. So for every 2, you can take out 1. Only one of you is going to survive this. You learn a lot about romance in math class, right? Cosine squared plus sine squared is 1. Wedding invitations, breaking up. So there's where we get the square root of 17 from. So I'll set up the rubric so you have those steps. So you'll see it on the right. It will say something like broke up the square root correctly. Something like that will be on the right just to flag you and remind you. So the hypotenuse is 5 squared root of 17.
So when you took out the 5, the other 5 disappeared?
Right, because when you, what happens when you have 3 times 3? It's 9, right? When you take the square root of 9, you get 3. You only get 1 3 back.
Oh, okay.
That's why.
Thank you.
Step 2, you find, now you're home free. Use the angle formulas from the triangle to get the sine and the cosine. Sine is opposite over hypotenuse. And notice I've labeled the triangle so that an opposite is labeled opposite and adjacent, because I think some of you on the quiz, I felt you were confused of where the location of adjacent was. So adjacent means right next to the angle, and opposite means across from the angle. And that's minus 5 over 5, and this is the fun part of math, crossing things out. You get to cross those 5s out, and you're left with minus 1 over square root of 17. Now notice that in the little box, this is my version, they actually have the answer sitting there. You see next to the sine theta, they actually got water out of the basement. They multiplied top and bottom by square root of 17. That's okay. Here's where it's really good that they have a maple thing inside it. You can actually plug in right into the top, you can plug in 1 over square root of 17, and it'll give you that it's correct. It will still be okay. So there's some good things about it. Cosine theta is adjacent over hypotenuse. Let me back that up again. 20 over 5 square root of 17. We just put the numbers into place, and you see that you can reduce here. You get a slash out here too. So I'm left with 4 over square root of 17. And I can plug that directly into this blank over here. I can actually plug in 4 over square root of 17 into that blank, and it will accept it. One thing I want to note is if you don't have these thetas inside your work, I'm going to count it off. There's a relationship with having notation errors and having errors at the actual errors. So the more clean you get, I hope that the better solutions you have. So that's what I'm doing. I'm not doing it to hurt you. That's why I'm actually warning you in advance that if you forget to put the angle there, for a couple reasons. Number 1, I believe that you're going to get better at doing them if you're more careful as you're going along. And number 2, you're going to leave the class one day and sit in someone else's class, and I want them to know you're smart. So if you leave off the theta, they start to think, well, that person doesn't really know what they're doing. And that's when you say you had Dr. Song for pre-calc. We'll have to have him come here. We'll have him do a guest lecture.
Is that like the little 2?
This thing is it's a Greek letter, theta. I think they use thetas for angles because the Greeks were obsessed with geometry. They were really obsessed with geometry. Like all these ideas of angles, hypotenuse, they all came from the Greeks. Oh, yeah, it looks better up here than on my computer. Tangent theta is opposite over adjacent. Plug them in, you get minus 1/4. Notice that I can actually see that it's minus 1/4 up there. You can actually, I can realize that my answer is the same thing as the answer. That's not going to happen to you because you don't get the answers unless you put a bunch of wrong answers in there, then you get the right answers. So see how I just plugged them in there so you can see. The reason I'm doing this is because of your feedback to me that you were frustrated. It wasn't just Poema. There was a couple of you had sent me emails saying that you were confused with what Webassign was asking. So keep it up. I won't know unless you tell me. So that's why I put that there so you can see not just the answer, but what's okay. Now, how do you do cosecant thing? Well, you just use that red list that everybody's getting that right. The 4 things that didn't happen last semester. Everyone's getting it right. So in that red list, you just pull off from the red list, which is on it's on your test. You can rip your test apart. I'll bring a stapler here. You can just rip that off and say, okay, what's cosecant? Well, it's 1 over sine, and 1 over that. And now I have, it doesn't matter, I have a fraction over a fraction. What do I do with a fraction over a fraction? Invert the denominator and multiply. Hey, good, you can make those little, at the same time when you say that, then people really think you're nuts. Invert the denominator and multiply. Invert the denominator and multiply, I get minus square root of 17. And look at that. It's the same thing that the answer came.
Wait, why is it negative?
Because the answer I got from the previous thing was negative.
Yeah, but one and the negative one cancel out, right?
No, the ones cancel out, but the negative stays. I usually scoot the negative to the top to avoid confusion. If there was a negative one here, right here, then they would cancel. But since I have a positive one and a negative, I still retain the negative. Good to go? All right, next, secant. 1 over cosine from the red list. Same old drill. Fraction over fraction, invert the denominator and multiply. My son was the one that said you should shout it once in a while too. Mix it up. Mumble it. Now you can use your hands, shout. I know some of you take public transportation. You're guaranteed a seat every time. They would just part like the Red Sea. There she comes. There she comes. Square root of 17 over 4. You get a seat and you memorize all your math facts. 2 birds with 1 stone. See, at West Point, I used to teach at the military academy. That was a dream for me. Every morning, line them up. And then make them say their math, all their laws of exponents. Ma'am, x to the m times x to the n is x to the m plus n. I was in a dream world. Dream world. I had all their facts down. They had to do it. They had no choice. It was interesting. It was not a good job for right after you get your degree, because I didn't quite know where I was at. But it was interesting. In hindsight, it was nice. Okay, so cotangent, well, that's cosine over sine from your red list. There's another way to do this. It's also 1 over tangent. But I'm going to stick to the red list so that I'm uniform with what I'm showing you. That's 4 over square root of 17 over minus 1 over square root of 17. Invert the denominator and multiply. They cancel, and I'm left with minus 4. Sound reasonable? Adele, question? No, you won't. That's the whole point, right? It's nice to be in my position now because I don't have to worry about being tenured or promoted. Everything I do is for the reason of because I want to. And so it's a nice position for me to be in. So I can watch what other professors say when they see students in higher level class and say, they didn't learn this. So I can think about how can I make sure they retain it. It's not about the list for now, it's about the list for later. So this is my idea. Like, keep drilling it again and again and you retain it. You can't help it.